Okay, so now we're going to work on example 9. It says find the vertex and graph the function f of x equals negative 2x squared minus 4x plus 6. And we're going to use this formula right here. It asks us to first find the vertex. And so what we want to do is we want to figure out what negative b over 2a is equal to. So our b value is negative 4. And then 2 times our a value, which is negative 2. And so now we just want to simplify that. So negative 1 times negative 4 is positive 4. And then 2 times negative 2 will make our denominator negative 4. And if we simplify that, that ends up being negative 1. Now, if you're still unsure of what this number represents, this is the x-coordinate of our vertex. So since we have the x-coordinate, then we can use that to figure out the y-coordinate of our vertex. So we're just going to take negative 1 and plug that into our function. So we get negative 2 times negative 1 squared minus 4 times negative 1 plus 6. And let's go ahead and simplify that. So we get negative 2 times 1 plus 4 plus 6. And that simplifies to 8. So then this value here is the y-coordinate of our vertex. So the first part of the problem asks us to find the vertex, so we want to explicitly state that out. So our vertex is the ordered pair negative 1, 8. And then the second part of the question asks us to graph it. So let's go down here where we have a grid available. And let's just remind ourselves our vertex was negative 1, 8. So I'm going to go ahead and draw in my axes. So this is my y-axis and this is my x-axis. And our vertex was negative 1, 8. So that would be right here. Okay, and then just for good measure, let's plug in one additional point into our function so that we have a better idea of what our graph will look like. Now, remember that our function is f of x equals negative 2x squared minus 4x plus 6. Another thing to note is that this is currently in standard form. And remember that one of the things that standard form is good for is figuring out the vertical intercept or the y-intercept. And in this case, if we plugged in 0, the first two terms would disappear and our output would just be 6. So that's kind of helpful in this scenario. So 0, 6 would be right here. And since we know that the vertex is, in this case, the highest point, since our a value is a negative number, that means that our graph is going to look something like that. It's going to be a frowny face. So our vertex is the highest point, but the vertex is also kind of the location at which our graph is being mirrored. Sometimes you'll hear the axis of symmetry. All that means is that imagine a line, a vertical line going down the vertex. Here, let me kind of draw a dashed line here. And the axis of symmetry just says that all of the points are mirrored or symmetrical around that line. So if one of the points on our graph is 0, 6, then we know that another point on our graph would also be -2, 6, which is this point right here. So now that we have 3 points, I think it's good to go ahead and start forming our graph. So it's going to look something like that. But why don't we just take it one step further and try to figure out what our x-intercepts are as well. So let me erase this portion so I have some room to figure out what our x-intercepts are. Okay, so there's our function, and notice that our a value is not equal to 1, and so I would suggest trying to factor this using the Xbox method first, and then if that doesn't work, then we can always use the quadratic formula. Let's go ahead and see if that works. On the top, I'm going to put our b value, and on the bottom, I'm going to put a times c, which is -12 in this case. And look at that, we want to find two numbers that add to -4 and multiply to -12. And I can think of two numbers that do that for us. There's -6 and +2. So I'm going to go ahead and rewrite my equation as -2x squared minus 6x plus 2x plus 6. And now I'm going to create my box. And remember, the x squared term goes in the top left corner, and then the bottom right corner is the constant term. And then the other ones, you can put them in either position that remains inside of the box. So here I can factor out a -6. In the top row, I could factor out a -2x. In the first column, I could factor out a -2x, and in the last column, I could factor out a 2. So let's go ahead and write that out now. So we have -2x minus 6 times -2x plus 2 is equal to 0. Now, I can set both of these things equal to 0 and solve for x. So if I solve those, then we get x equals -3 and x equals +1. So what that means is that our x-intercepts are the points 1, 0 and -3, 0. So I'm going to go ahead and plot those. On my graph. And so our graph is going to look something like that. All right, so that is the graph of that function. And don't forget, it asked us for the vertex, which I've boxed up at the top there. Okay, so the next topic that we want to look at is called the average rate of change. And so if we have a function graphed, like in the blue here, we have the graph of some function f, and we're looking at the average rate of change between two x values. So here we have an x value of a, and here on the x-axis we have b, and we're looking for the average rate of change between those two x values. Then the average rate of change is given by this formula, f of b minus f of a divided by b minus a. And what that represents is that is just the slope of this green line here. And this green line is also called the secant line, which is just the line that goes through these 2 points here that we're looking at. So another way of saying the average rate of change is the slope of the secant line. Okay, and it looks more complicated, I think, than it really is. So let's jump into an example. It says find the average rate of change of the function f of x equals 8 plus 3x plus 0.5 x squared between x equals 2 and x equals 4. So what we want to do is we want to follow the formula. So our average rate of change is equal to f of b minus f of a over b minus a. And notice here our a is 2 and our b is 4. And those are just the numbers on the x-axis. Okay, don't get those confused with the a and b values of our quadratic function. Those are something different. These are just the, like, a just represents the first value on the x-axis, and then b represents the second value on the x-axis. So don't get confused by that. Okay, so if I plugged in those numbers now, really we want to evaluate f of 4 minus f of 2 and divide that by 4 minus 2. So in order to figure that out, we need to solve for f of 4 and f of 2. So anywhere I see an x, I want to replace it with a 4. I'm going to rewrite 0.5 as 1/2. So if I simplify that, we get 8 plus 12 plus 1/2 times 16, which is 20 plus 8, so that's 28. I'm going to move this down a little bit. So f of 2 is equal to 8 plus 3 times 2 plus 1/2 times 3 squared. I wrote down that value wrong. Sorry, this should be a 2, not a 3. All right, that looks better. So then we get 14 plus 2, which is 16. And so now we know that f of 4 is equal to 28, and f of 2 is equal to 16. So now I can replace those values here and do 28 minus 16 over 4 minus 2, which is 2. And then 28 minus 16 is 12. And then that's just going to be 6.